How do you prevent cross-site scripting, XSS, attacks? Imagine visiting a website and suddenly seeing malicious code run in your browser. That's what cross-site scripting attacks aim to do. They inject harmful scripts into web pages viewed by others. These scripts can steal data or hijack user sessions. To stop this from happening, you need to follow some simple but powerful security steps. First, always treat user input as untrusted. Check that data matches expected formats and remove or encode any suspicious characters before storing or processing it. This stops malicious code from sneaking in through forms, API calls, or URL parameters. Next, when sending data back to users, encode it properly based on where it will be used. For example, encode for HTML if displaying content on a web page, or for JavaScript if inserting data into scripts. This makes sure browsers interpret the data as plain text, not code. Another key step is to set up a content security policy. This is a set of rules that tell browsers which sources are trusted for loading scripts. By defining strict policies, you can block any malicious scripts even if they slip through. Using HTTP-only cookies is also important. Mark cookies as HTTP only so scripts cannot access or modify them. This reduces the chance of session hijacking if an attacker injects malicious code. Never execute raw JavaScript from user input. Avoid inserting user data directly into script tags or event handlers without proper sanitization. Always use your framework's security features. Many modern frameworks automatically encode output and provide safe templating options. Relying on these tools instead of writing in safe code. Regular security testing is vital too. Use automated scanners and manual checks to find vulnerabilities early. Incorporate these tests into your development process so issues are caught before deployment. Educate your team about XSS risks and prevention. When building APIs, validate all incoming data and encode outgoing data, especially if it will be rendered in browsers. When storing user content in databases, sanitize inputs before saving and encode outputs when retrieving data for display. Apply content security policy, headers in server responses to instruct browsers on trusted script sources. Use secure cookie flags set by your server to protect user sessions. Leverage your framework's security utilities and avoid unsafe coding patterns that bypass protections. Following these steps creates multiple layers of defense. It makes it much harder for attackers to exploit cross-site scripting vulnerabilities and helps keep your application and users safe.